Today's Leetcode challenge is to find the intersection of two linked lists. The input here is in the form of two linked lists, linked list 1 and linked list 2, and we have to find the point where these lists are intersecting. So input is list A and list B, and output will be the intersecting point between these lists, and in case there is no intersecting point, then the output would be null. Let me explain the examples given. Example, length of list B is greater than length of list A, and intersecting point between list A and list B is node 8. This one. Moving to the second example, here length of list A is greater than length of list B, and the intersecting point between list A and B is node 2. And third example is this one. Here length of list A is greater than length of list B, but we couldn't see any intersecting point between list A and list B, so it will return null as output. So these are the three examples being given by Leetcode. Solve this problem with two approaches. Let me start with the first approach. Here we can find the length of these two lists, and then we can iterate over the list which is having more length, and after that we can start iterating the list simultaneously till we get an intersecting point. So I'll explain this. Firstly, we can calculate the lengths of the list. The length of list A is 4, 1, 8, 4, 5, which are 5 nodes in total, making it 5. Then calculating the length of list B, which is having list nodes as 5, 6, 1, 8, 4, 5, 6 in number. Now we can calculate which list is greater, 5 or 6, 6. So we could interpret that list B is greater than list A by how much nodes? 6 minus 5, which is 1. So we can iterate list B by one node. So the current pointer of list B would be now, instead of 5, it will iterate via one node and it will come to point 6, and current pointer of B will be 6, and current pointer of A will remain as it is, that is the head, and it will 4. Now both start iterating both the list parallelly, list in parallel, till current pointer of A equals to current pointer of B. So we can start iterating both the list in parallel till we get a point where current pointer of A is equals to current pointer of B. We can use while loop for this, and we can also check for one case where either of current pointer A or B is null. So this covers the case where there is no intersecting point. So we can have one while loop which we can iterate till the point head A is not null or current pointer A is not null, and head B or current pointer B is not null, and head A is not equals to head B. So these are the 3 points. And how can we calculate the output then? So while loop will break in 3 cases. One is either head A comes to null or head B comes to null. So in that case, we can interpret that there is no intersecting point and we can return null. And the other point is where head A equals to head B. In this scenario, it will break here at node 8. So we can return head A in that case. So that's one of the approach. So the time complexity in this case will be if length of list A is m and length of list B is n. So we need to iterate over both these lists once. So it would be om plus on, and the best case scenario is the intersecting point is at the starting of both these lists. In that case, we need not to iterate over both the list till end. So that's the best scenario. And there the worst case scenario is where the intersecting point is at the last of both these lists. In that case, we need to iterate over both these lists twice. So it would be O2 times m plus n, and we can drop the constants. So it would be om plus on. And the space complexity here would be O of 1 constant. So that's one of the approach. I have implemented this approach here. So we are having this method get intersection node. I have calculated the length of both these lists, and if the length of list A is greater than length of list B, then I can iterate head A to the difference between both these lists. Similarly goes for if length of list B is greater than length of list A. Here is the while loop where I am checking if head A is not null or head B, and head B is not null and head A is not equals to head B. So in that case, I am just iterating over the list. The point, if any of these conditions fails, it will check if head A is not null. That means we got an intersecting point. It will return head A. Otherwise, it will return null. So yes, that's one of the approach. The second approach here is it takes constant time, which is om plus on, but this space complexity it takes is om. So that is using hash map or any data structure like hash set we can take. So we can start iterating over list A, and we can store the nodes in key. Iterating over list A, and we can store nodes in key. So after iteration, my hash map is having key node 1, 9, 1, 2 and 4 in it. Then I'll start iterating over list B, and yes, I can also start searching the list B elements in hash map. If the hash map already contains the element, that means that's the intersecting point and we can return that point, otherwise we can return null. So in this case, let's start iterating over list B. The elements in list A are list A has node 1, 9, 1, 2 and 4. So these are the elements which are present in hash map as key, and value I can give 1, so that's alright, or I can use hash set as well. Now start iterating over list P. The first element is 3, so it will search for 3 in this list, and no, it couldn't find. The second element is node 2, it will search for node 2 in hash map key and it's present here, so we'll return 2 as answer. So that's the second approach. The space complexity here is OM, where M represents the length of list A, and list A length is M and list B length is N. And the time complexity would be OM plus N, so it will be linear in this case. So we can use any of these two approaches, depends on what the requirement is, whether we want space complexity to be less or we want time complexity to be less. So that's it for this problem. Thanks again for watching this video. Thank you.